What's up guys? Welcome to Venom Prunov Academy. In this video, we are simply going to look at the tricks of solving rational numbers. We looked at the original way or the most accepted way of solving questions dealing with rational numbers, but in this one, I simply want to show you a trick that is going to help you find the solutions within seconds. Okay? Yeah. So remember, we said rational numbers are simply numbers that can be expressed as a fraction in the form of a over b, and we gave a lot of examples. Okay, so let's quickly look at questions and how you're supposed to use this trick. So let's consider 0.3 bar. Okay, and we said when you've got a bar, it simply means you've got 0.33333 because 3 is recurring. Okay, so in this trick, the first thing that you do is draw a line. When you draw a line, then remember the concept that every number under a bar represents a 9, okay? Or each digit under a bar represents a 9, okay? And now that you've got one digit that is reoccurring under the bar, it simply means you've got 1 9, and you're going to put every digit that is under the bar as a denominator, okay? So since we've got 1, just put a 9 on the bottom and then put a 3 on top. Okay, so this is how you're going to do it. And from here, you simply reduce it. 3 into 3, 1. 3 into 9, it's 3. So this is your final answer. Okay, see, this helps you to find the answer in a short period of time. Okay, another example that we are going to take is 0.27 bar. Remember, first thing, draw a line. Then remember that every number or every digit rather under the bar is representing a 9. And how many digits do we have? We've got 2, so that means we've got 9. Then you simply take the 27 and put it on top. Then you reduce it. 9 into 27, it's 3. 9 into 99, it's 11. Okay, so this is how simple this method is. But then I want us to look at something different. What if you've got 0.215 and 5 is the only digit that is reoccurring? So what you do is you draw a line. Then remember, every digit under the bar represents a 9, but every digit that is after the decimal point and is not under the bar represents a 0. So in this case, what you're simply going to do is put a 9, which is simply replacing the 5, which is under the bar. Then you put 2 zeros because we've got two numbers that are after the decimal point and they are not reoccurring. Then on top, you put this entire number, which is 215, but you subtract the numbers that are not reoccurring or the numbers that are not under the bar. And these digits are 2 and 1. So you simply subtract 21. Then you work it out. So what is 215 minus 21? This gives you 4. This gives you 1. So it gives you 9. So you get 194 divided by 900. So you reduce this. You look for common factors. If it can be reduced, you reduce it. If it can be reduced, then you leave it here. Okay? So the last example that we are going to look at is a number that, let's say you've got 2.0. Okay, let me not say 2.0. Let me simply say you've got 2.321 bar. Okay, 1 is reoccurring. So realize that whenever you've been given such type of a number, it simply means you've got 2 plus 0.321 reoccurring. Okay, yeah, so what you're going to do is you're going to work out this. Okay, remember every number under the bar represents a 9, and all the digits that are not reoccurring represent 0. So you put this, and then you put the entire number, which is 321, then minus 32 because 32 is not reoccurring. So you subtract this. Then you work this out. What is 321 minus 32? We get 9. Then we get 8. Then we get 2, which is 289 over 900. You can reduce this if it's reducible, but remember I've got a 2 this side, so you come and complete the fraction here. 2 plus 289 over 900. Okay, over 1. You cross multiply. This is 2 times 900 plus this is 1 multiplied by 289 over 1 multiplied by 900, which is this. Okay, so this is going to give you 1800 plus this is going to give you 289. This is going to give you 900. So when you add these two numbers, 289, you get 9, 8, 10, 0, remainder 1 plus 2. So you get 2889 over 900. Okay, then you look for the common factors. If it can be reduced, you reduce. If it can't be reduced, then you leave it right there. So I just wanted you to know that you can solve rational numbers using this simpler method. It's not going to take a long time as compared to the first method that we looked at, which is the most accepted one. So this one, you use it when you're running out of time, or when you're dealing or you're undergoing certain competitions, for those that take part in school competitions. Then there's something that I want us to look at, which is certain questions that you're going to encounter, asking you to find a certain number of rational numbers that are existing between two rational numbers. So they can give you numbers like -3/2 and 4/3. Then they ask you to say, find the rational numbers existing between these two numbers. So the first step is you have to ensure that both of these fractions possess the same what? Denominator. How are you going to do that? Others are simply going to say cross multiply the denominator, get the denominator for this fraction and multiply it by this fraction, okay? And get the denominator for this side and multiply it by this fraction. So in that, it doesn't mean it's only going to multiply with the numerator, but it multiplies both. So you say -3/2 times 3 times 3, and this side you also say 4/3 times 2 times 2. What do you get? You get -9/6. This side you get 8/6, and they've got the same what? They've got the same denominator. So from here you can now start listing. After -9, what do you get? -8/6, -7/6, -6/6. Then you go to -5/6. So see, until you reach 8/6. That means you can list several numbers or several rational numbers that are existing between these two numbers. Thank you very much, guys, for watching this video, and I hope it was helpful. And if it was, please don't forget to subscribe, to like, to share, and to also hit that notification button so that every time we post or upload a new video, you guys will be notified on time. Thank you for watching, and God bless you.